Differentiation is a process of finding a function that outputs the rate of change of one variable with respect to one another variable. Differentiation and integration was developed to improve this understanding. Differentiation and integration can help us solve many types of real-world problems. We use the derivative to determine the maximum and minimum values of particular functions, for example cost, strength, amount of material used in a building, profit, loss, etc. Derivatives are met in many engineering and science problems, especially when modeling this behavior of moving objects. In Rolle's theorem, suppose fx is a function that satisfies all of the following. First, fx is continuous on the closed interval a, b. Second, fc is differentiable on the open interval a to b. And the third, fa equals to fb. Then there is a number c such as a is smaller than c and smaller than b, and f prime c equals to 0. Or in other words, fc has a critical point in AB. For the mean value theorem, suppose fx is a function that satisfies both of the following. Fx is continuous on the closed interval a to b. Second, fx is differentiable on the open interval a to b. Then there is a number c such as a smaller than c smaller than b, and f prime c equals to fb minus my fa divided by b minus a, or fb minus my fa equals to f prime c multiplied by b minus a.
Rolle's theorem and mean value theorem for differentiation is one of the applications of differentiation in fundamental theorem of calculus. The mean value theorem is one of the most frequent subjects in mathematics educational literature. It used to prove a host of other theorems in differential and integral calculus. As a curiosity, it is most frequently derived as a consequence of its own special case, Rolle's theorem. Rolle's theorem is named after Michael Rolle, a French mathematician. Usually, Rolle's theorem is used to prove the mean value theorem, which Rolle's theorem is indeed a special case. Let me give you an example. A trucker traveled 162 miles on a toll road with a speed limit of 70 miles per hour, and he completed the journey in 2 hours. At the end of the toll road, the trucker is issued with speeding limits. Why? Well, since the truck position is continuous on the closed interval, differentiable on the open interval, there were no discontinuities on the position graph. The truck passed through every point on the way to toll booth to toll booth. There were no wormholes or teleporters to create a hole, and the curves in the position graph would not be so fun if you were traveling 70 miles per hour. The mean value of theorem applied here. It states that at one point the average velocity of the trucker must be equal to instantaneous velocity of the trucker, and since average of velocity equal to total distance or displacement divided by total time. So this is the calculation. 162 miles divided by 2 hours equal to 81 miles per hour. Then at least one time on the toll road, the trucker was going 81 miles per hour, which well overing the speed limit, because the speed limit is 70 miles per hour.
In Rolle's theorem, there are two important conditions that we need to satisfy, which is Fa equals to Fb and F prime C equals to 0. So let's go to the question. Find the value of C that satisfies the Rolle's theorem for the function fx equals to x squared minus 3x plus 2 in the interval of 0 to 3. The problem here is we need to find the value of C that satisfy the Rolle's theorem, which is the FA equals to FB and the F prime C equals to 0 in the function. Okay, now we go to our problem solution for the function fx equals to x squared minus 3x plus 2 in the interval of 0 to 3. So we know that 0 represents A and 3 represents B. So we need to substitute 0 and 3 in the function. f0 equals to 0 minus 3 times 0 plus 2 equals to 2. And f3 equals to 3 squared minus 3 multiplied by 3 plus 2 equals to 2. So the f0 and equals to f3 has the same value, which is 2. So the first condition is shown. For those who didn't know that f prime c is actually is the same as f prime x. F prime x, which is actually the differentiation of x. So now the function needs to be differentiated. After we get f prime x equals to 2x minus 3, replace the x with c. So we get f prime c equals to 2c minus 3. So back to the second condition, which is f prime c equals to 0. So we apply the function in the equation, which is 2c minus 3 equals to 0. Now the negative 3 we can bring to the right side. So 2c equals to 3. C equals to 3 over 2. So the last answer will be C equals to 3 over 2 is the element to the interval of 0 to 3. Mean value theorem for differentiation states that fx continues to the closed interval of a to b and fx differentiable to the interval or open interval of a to b, and there is at least one point C in AB. The point C in AB creates a formula that we can use to solve the solution for the function, which is f prime c equals to fb minus fa divided by b minus a. So the question and the problem here is to find the value of c that satisfies the mean value theorem for the function fx equals to square root of x plus 5 to the open interval of 4 to 11. Now for the problem solution, for the function fx equals to square root of x plus 5 to the open interval of 4 to 11. So we know that 4 represents A and 11 represents B. So now we have to substitute 4 and 11 into the function of fb and fe. So now we get fb equals to f11 equals to square root of 11 plus 5 equals to 4. Then fa equals to f4, which we have been substituted, equals to square root 4 plus 5 equals to 3. Now the next step is to have b minus at a. Remember, and please be careful that b minus a is 11 minus 4 and not the fb minus the fa. So basically, all the methods that we have done before is actually for us to put it in the formula to find the solution. So now we have to find the f prime c, but we only have f prime x, but actually it is the same thing, but the differences is between x and c, and we can substitute the x with c. So now we need to differentiate the function of fx. Okay, how to differentiate the function of fx equals to square root x plus 5 is where we put the power of 1 over 2 in the front of the equation, and the power of 1 over 2 is minus by 1. So after that, we multiply 1 with x plus 5. So after differentiation, the result will be 1 over the square root of 2 x plus 5. So it goes the same as f prime c, because we substitute the c with in the f prime x. So how to use the formula? It's actually easy because we have already found each of the value that we need to insert in the formula. So for f prime c, it is 1 over the power of 2 c plus 5, and then for fb and fa, we already got the value, so we only insert it in the formula. So after all the calculation, we should get c equals to 7 over 2 the power of 2 minus 5, and the last answer will be c equals to 7.25 is the element of the open interval of 4 to 11. So that's it.
So the conclusion is, we must acknowledge to differentiate the Rolle'S theorem and mean value theorem by their condition, and finding the value of c in function that satisfy the theorems. And the third is a formula that we can use to solve solution is the mean value theorem.